So today we are going to discuss impact test of material. So this is the impact test machine. So this experiment aim is to find the impact strength of material, impact strength of given specimen. You can find impact strength of any material, mild steel, aluminum, any material impact strength you can find. So determine the impact strength of material. This is the aim of experiment. This equipment required. This is the impact test machine, and the standard specimen is there, standard test piece and vernier caliper. So this is a standard test piece. Standard test piece height is 75 mm, and up to notch distance this is a 28 mm. So notch V groove is provided on the specimen. So this V groove distance, one edge, one top to V edge, that is 28 mm. Total height is 75 mm. Top to V groove notch distance is 28 mm. Okay, sir. So we have to prepare the specimen before conducting experiment, and we have to fix the specimen here in this position vertically. So using this machine, we can conduct two experiments. One is the IZOD test, second one is the Charpy test. Two different standards. According to international standards, there are two standards are there. One is the IZOD standard, another is the Charpy standards. Using these two standards, we can find the impact strength of the material. Okay, impact strength refers to the toughness of the material. So toughness, it is the property of material, energy absorbed by the specimen before fracture. So here we are going to find the toughness of this notch, toughness of this material. We are going to find the toughness of this material, how much energy it is absorbing to fracture, we are going to find. So here the specimen is fixed, this position specimen is fixed vertically, and if you see this dial here, this dial is there in this test. So outer scale represents Charpy test and inner the circle represents readings IZOD. So outer scale readings are there, these readings are Charpy readings. So inner scale readings are IZOD readings. So see the pendulum, this is called pendulum. This is the pendulum, this is the weight, some weight is here. So here load is released from this position, load is released. So load released from this position to specimen. So specimen is located here. To fracture the specimen, how much energy is required, we can find using this equipment. Okay, if you see the equipment, this is the pendulum. Pendulum position is 90 degree. This is the weight of the pendulum, about 9 kgs weight pendulum. So we are releasing this pendulum. Mass of the pendulum into gravity into height, that is the energy, that is the potential energy. Now here this is the potential energy. So if you release this weight, so potential energy converted into kinetic energy. So the kinetic energy is absorbed by the specimen to fracture. See the readings here. So maximum reading, you see 168 joules. Coming to IZOD test, 168 joules. Coming to Charpy test, 300 joules. This 168 joules released from this position. So now we have to keep here in this manner. That means 168 joules released from this position. Okay. So Charpy IZOD test difference is there. We have to fix this pendulum. In the Charpy test, position of the pendulum is different. In Charpy test, position of the pendulum is 121 degrees. So mass of the pendulum is same, gravity is same, but only thing is height is different. Height is, if the pendulum is clamped 121 degrees, height going to change. So that becomes 300 joules. So in this position, energy released 168 joules in this position. If you clamp the pendulum here, the holes are there. Okay, pendulum is clamped in this position, 300 joules we can release from this position. Okay, so now I will apply the load. I will release the lever, release the pendulum from this position. So let us see how much energy absorbed by the specimen. Okay, this two specimen, one specimen is already there fixed. Okay, one specimen already is fixed. So now I am checking the energy absorbed by the specimen. Okay, so before that, for taking the specimen preparation, we have to take the piece, rectangular cross section piece, square cross section piece, and we have to mark the dimensions, notch dimension, and total height we have to mark, and we have to cut accordingly as per standard, as per universally accepted standard, as per ASTM standard. Okay, now I will release the energy. Okay, I will release the energy. See the here I am keeping the pendulum 168 joules position, because here we are applying the load 168 joules. Okay, so how I am applying the load, please watch. Okay, so now the safety, this is called safety clip. This is a safety clip is there because this energy is there. So we are using safety clip to stop the pendulum. Okay, so safety clip is removed and I am applying the load. See, I am applying the load on the specimen. So now see here. So here 300 joules is released in this position. So now see the readings. You see the readings here. So that is a two. We have to consider inner circle scale for IZOD test, outer circle for Charpy test. You see the reading 80 joules. So 80 joules is 80 joules absorbed by the specimen. 80 joules energy is required to break the specimen. See, we have applied 168 joules, but the specimen required 80 joules. 80 joules reading is there. So impact strength equal to energy by area of cross section. So energy absorbed by area of cross section. Here this is impact strength equal to energy absorbed 80 joules per area of cross section. What is the area of cross section? This is the area of cross section. This is 10 by 10 area of cross section. So 80 by 10 by 10, 80 by 100. 80 by 100 equal to 0.8. 0.8 joules for mm square. This is the impact strength of the material. So impact strength formula I equal to K by A. K is the energy absorbed by the specimen. Denominator area of cross section. Energy absorbed by the specimen 80 joules by area of cross section is 10 by 10. So impact strength, this is the I, impact strength equal to K by A. So here K is the energy absorbed by the specimen, K by A, area of cross section. This is energy absorbed by the specimen to fracture, by specimen to fracture. By this is the area of cross section. This is the area of cross section. So here I equal to, we got 80 joules is the energy absorbed by the specimen, and area of cross section is, this is the 10 by 10. 10 by 10 is the area of cross section. So equal to 80 by 100 equal to 0.8 joules per mm square. This is the impact strength of the material. So I is the impact strength. Okay, impact strength equal to, we got 0.8 joules per mm square for this given mild steel specimen.